This is going to be our third lesson on transformations. This time I'm going to talk about translations. So what is a translation? Translation occurs when you have a shape. For example, I have this shape. And I move the shape from one place to another. Look, I'm just moving the shape around. It can be horizontal, it can be vertical, it can be diagonal in any direction. Okay, so this is going to be our translation. Now, translations are carried out using vectors. So we use vectors to translate a shape. A vector has two properties. A vector has a size and shows a direction. In our case, we're going to be limited to knowing what is the direction. We're not going to be asked for the size of the vector in this topic, so I'm going to limit myself to showing how to find the direction using the vector. Now, a vector is written as, it is written in the form x, y, where x is the displacement of a point along the x-axis, while y is the displacement of the same point, but this time along the y-axis. Let's take a small example. If I have the point, for example, translate the point P 4,2 using vector 6, 3. That is the vector. What we're going to do, let's see our grid. So we have 0, 1, 2, 3, 6, 7, 8, 9, 10, 4, 5, 6, 7, 8, 9, and 10. This is the y-axis. This is the x-axis. So I have the point 4,2. 4,2 is this point here. This is point P. We're going to translate the shape using vector 6, 3. So on the x-axis, I need to move by, that's the x, I need to move by 6. So it's 4 moving 6. So it's 1, 2, 3, 4, 5, and 6. So this is where we have arrived until now, and we have to move by 3 on the y-axis. So it's 1, 2, 3 on the y-axis. So our new point P is going to have coordinate 10, 5. So we need to see the vector from there till there. Right? So that is our vector. This is the place 10, 5 where our original point P has finished up. Now, normally we're going to have shapes, triangles, quadrilaterals, any other shape which we would need to translate. But let's see what's happened here. Our coordinates were 4,2. That was our original shape. It ended up as 10, 5. Is there a short way how to find that point? If we notice 4 and 6, x and x, 4 and 6, 10. 2 and 3 make 5. So as a rule, for transforming using vectors. Um, Translation. As a rule, we add the x and y of the vector to the coordinate. So, if point P, x, y is translated using vector AB, the end product will be a new point P, x plus A, y plus B. Now let us see an example where we're going to perform multiple translations on a shape. So, example. Plot the shape ABCD having coordinates A minus 3, 2, B minus 5, 2, C minus 5, 5, and D minus 2, 4. Now translate the shape using the following three vectors. Vector number one is vector 10, 4. Vector number 2 is going to be vector minus 2 minus 5, and vector number 3 is going to be vector 5 minus 3. So we're going to see that transformation being done. First I'm going to start by plotting ABCD on a grid. I have 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 6, 7, 8, 9, 10, minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 1, minus 2, minus 3, minus 4. So our shape had those coordinates, minus 3, 2, minus 5, 2. I'm going to plot that shape. So it's minus 3, 2, that's A, minus 5, 2, that's B. And then we had minus 5, 5, and minus 2, 4, minus 5, 5, and minus 2, 4. This is our shape A, B, C, D. To draw the shape, so this shape A, B, C, D. Now we're going to transform the shape using the vectors. First vector was vector 10, 4. 10, 4 meaning I have to start from a one point, doesn't matter which point. For example, I'm going to start with point C. I'm going to move 10 on the x-axis, plus 10, and then 4 on the y-axis. So point C is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4. 1, 2, 3, 4. So my point C now is that point there. Same with D, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4. One can notice that I could have said D is just 3 boxes to the right and 1 to the left, and that's also 1, 2, 3 to the right and 1 to the left. Let's do this with A. A is 2 down and 1, so it's 1, 2 down and 1 to the left. So that's point A. And point B is exactly beneath. So I've done that by counting the squares. Okay, counting squares, counting sides. So that's my shape. Let's draw the shape. That's the first one. That's the first one. Now I'm going to do the same thing, but now having vector minus 2, minus 5. And now I'm going to use the working. Okay, so we'll have some working. Let's consider point A now. Let's consider point A. Well, a point A which has coordinates minus 3, 2. And I need to translate that using vector minus 2, minus 5. So minus 2, minus 5. If I add, I get minus 5, minus 3. So I'm going to do that. Minus 5, minus 3. So that's point A. Now, knowing that the shape is going to be just translated, so moved about, point B is going to be 2 to the left, point C 3 up, and point D 3 to the right and 1 down. And that is our shape. And that is the third shape. Alright, so this one was translated using vector 10, 4. This was translated using vector minus 2, minus 5. Now the last one was a translation using vector 5, minus 3. Again, I'm going to choose one point and add, it's a nice shortcut. I'm going to choose point B, which had coordinate minus 5, 2. This time minus 5, 2. The vector, because I forgot the vector, the vector was 5 minus 3. So I'm going to add 5 minus 3. The result is going to be, in this case, 0 minus 1. So my point B is 0 minus 1. Now I know that A is 2 to the right, C is 3 up, and D is 3 to the right and 1 down. That's point D. I'm going to draw the shape now again, as I've done the last time. So I have now the shape that was translated using vector 5 minus 3. Okay, so this is our original shape, and the other three are our translations. So that's how to find a to form a translation. To find reverse, to find the translation, we just need to add squares. So let's search a small example. We've got a shape. Let's say this is shape A, let's say this is shape B. We have to describe, we need to describe the transformation which maps A to B. We choose a corresponding vertex. So for example, I'm going to choose this vertex, and I'm going to say that vertex. So how much do I need to move on the x-axis, and how much do I need to move on the y-axis? Right? On the x-axis, this is 1, 2, 3, 4, 5, 6. On the y-axis, this is minus 1, minus 2, minus 3. So it is a translation. This is a translation using vector 6 minus 3. And that is our answer. I hope you have understood this. This is quite easy. It's very simple. when compared to the other two, which are reflections and rotations. I'm going to give you an example so that you can work out one problem alone. So, plot triangle ABC having coordinates A 2, minus 2, B 4, minus 2, and C 5, minus 4, right? Translate triangle ABC using the following vectors. 1 is going to be the vector 0, 5. Number 2 is going to be the vector minus 6, 8. And 3 is the vector minus 8, 0. Okay, label this P, label this triangle Q, and label this triangle R. Hope you do well. Thanks for listening.